Good morning, students. Okay, in our last class we had started dimensional analysis and we had discussed what do we mean by dimension, correct? No, and apart from that we had discussed how to calculate dimensional formula. Okay, and we had discussed some of the examples, and in those examples we had also discussed what do we mean by actually dimension and how to write dimensional formula. And in application of dimensional analysis we had started with to check the correctness of an equation. So in that same part only to check correctness of an equation. So I had told you this is nothing but first application number 1. Okay, from theory point of view they will be asking these manner of questions to check the correctness of an equation b is equal to u plus at, okay, or s is equal to ut plus half at square, and some more examples like v square is equal to u square plus 2as. Clear? So in today's class I will give you 2 homeworks based on this. Last class which we had discussed, in the same steps you should have to go. I will tell you what are in each formula, each term indicates what's that actually. Clear? So what is the meaning of each term also I will be going to give you. Clear? So first homework for you is nothing but centripetal acceleration A is equal to v square by r. Okay, this A is nothing but centripetal acceleration, which is nothing but basically acceleration. Clear? Next, this V is nothing but velocity of body or object, you can tell, velocity of the object, and R is nothing but radius of circular path. Okay, with the help of dimensional analysis you should have to check correctness of this equation. Clear? In left hand side you are having A is nothing but what? Acceleration. Right hand side you are having only one term, that is nothing but v square by r. Okay, so for this v square by r you should have to calculate what are the dimensions of that v square by r quantity, and the left hand side dimension should be equal to right hand side dimension. If it is in that manner, means you can tell that the given equation A is equal to v square by r is dimensionally correct. Okay, if you got different dimensions, means you should have to tell that the given equation it is not dimensionally correct. Clear? So you should have to calculate for A what is the dimensional formula, calculate. Next for v square by r, totally what is the dimension you have to calculate. Clear? And next one, this is one homework for you. F is equal to mv square by r. Okay, where F is nothing but centripetal force m is nothing but mass of body, v is nothing but velocity of body, r is nothing but radius of circular path. Clear? Shall I erase the board? Okay, these two are homework for you. Let me clearly tell you, A is nothing but acceleration. Clear? Acceleration means what? Lt to the power of -2. Okay, here v square you are having. V means Lt to the power of -1. R is nothing but radius. Clear? Dimensional formula for R is nothing but capital L. Clear? That is nothing but basically that is length. Next here F is nothing but force. Basically it is a force. Okay. F dimensional formula for force is nothing but what? Mass into acceleration, if you consider, means ml t to the power of minus 2. Clear? Yesterday we had discussed. And m is nothing but mass of the body. That means capital M. Dimensional formula for mass small m is nothing but capital M. Here v square you are having. V means L t to the power of minus 1. Okay. Again whole square. R is nothing but radius. Again you should have to go for capital L. Clear? So left hand side dimension should be equal to right hand side dimension. If it is both the left hand side dimension is equal to right side hand dimension, means you will be telling it as the given equation F is equal to mv square by R is dimensionally correct equation. Clear? So practice it off. Okay. Shall I erase the board? Clear? So the next application of dimensional analysis, that is nothing but application number 2. Yeah. In this, what we are discussing means to derive a relation or to derive formula between two physical quantities. Clear? To derive the relation, in simple words we can call it as to derive any formula to derive a relation between two physical quantities, we will be following the method of dimensional analysis. In examination, how they will be asking this means, first they will give you formula, okay, and with the help of dimensional analysis you should have to calculate and you have to derive that formula. Yeah. In some cases they will give you formula, in some cases they won't give you formula, they will be explaining in sentence manner. Clear? Let us consider an well-known equation which is nothing but F is equal to mv square by R. Okay, where F is nothing but centripetal force, m is nothing but mass of the body, v is nothing but velocity of the body, R is nothing but radius of the circular path. Whenever an object is moving in a circular path, centripetal force is given by mass of that body into square of product of square of velocity and divided by the radius of that circular path. In some questions they will be asking, in some time they will be asking, derive the relation F is equal to mv square by R directly, where F is nothing but centripetal force, m is nothing but mass of the body, v is nothing but velocity of the body, and next R is nothing but radius of the circular path. They will give formula and they will tell. In some cases what they will be doing means derive the expression for, they will use this sentence, derive the expression for centripetal force when an object is moving in a circular path of radius R and it is dependent on mass of the body and velocity of the body. Clear? In this manner they will be asking question. So however they may give you a question, how to solve this kind of, or how to derive formula means, first one we are going to consider F is directly proportional to, that means this force is proportional to, okay. Here actually it is inversely proportional to R, but we are deriving this, okay. We are assuming that F is proportional to m power a, that means here m power 1 we are having, clear, and next v power b, next R power c. That means this A, B, C we don't know. In sentence wise how they will be giving the force whenever an object is moving in a circular path, okay, the centripetal force experienced by the particle, it is proportional to, or that formula will be in terms of mass of the body, velocity of the body and radius of the body. You should have to derive a relation between all these physical quantities. Clear? So first step you will be writing it as F is proportional to m power a, v power b, r power c. We don't know a, b, c. Clear? We are calculating a, b, c in this method. Okay, this powers what we are having a, b, c. This a, b, c powers only we are going to determine. So if I remove this proportionality sign, means what I can introduce here? Can anybody tell me? F is equal to, yes, some constant, very good, m power a, v power b, R power c. Correct? So this equation I will be treating it as 1. In next step what we are doing means we are writing dimensional formula for each term. Clear? Writing dimensional formula for each term. Here, writing dimensional formula for each term. So here we are having f. So what is the dimensional formula for f? Can anybody tell me? F is nothing but what? Mass into acceleration. Clear? Mass into acceleration of the body is nothing but what? Force. Basically, clear? So how I can write it? Dimensional formula for f means mass of the body as m. Clear? And next, acceleration of the body. Acceleration of the body, how I can write? Velocity by time. Yesterday we had discussed. Velocity is nothing but what? Lt power minus 1 and divided by time one more time means the time will go to numerator. Minus 1 will become minus 2. Clear? Next step. This k is nothing but constant. Clear? We are not going to write dimensional formula for this constant. Directly we are writing for this mass. So for mass what I can write? Capital M. Correct now? For mass I can write capital M and whole power A as it is I will be mentioning. M power A. Clear? Next. What is this V? V is nothing but what? Velocity of the body. Velocity of the body is given by dimensional formula for velocity. Displacement by time. Clear? Displacement L time divided by time means Lt power minus 1. Okay? This Lt power minus 1 is nothing but what? For velocity. Whole power what I am having? The factor b. Clear? Next, one more term here I am having. What is this? R power c. R is nothing but what? Radius of the circular path. So radius means what I can write? Can anybody guess? Length. Clear? That is nothing but L power c. Clear? L power c. So now next what I am writing here means this mlt power minus 2 I am not touching it as it is I will be writing mlt power minus 2. Okay, and here also I will be writing in the manner of mlt only. Look how I am going to write. So here I am having m power a, correct now? So m power a. Next L I should have to take. Here m, initially I was having m, so first I had written m. Next here I am having L. So L power I should have to write. So L to the power of. Here just check what we are having. Lt power minus 1 whole power b means it is nothing but L power b. Okay. So directly I can write, or if I want to take one more step here means I can write L power b. T power minus 1 into b is nothing but minus b. Correct. So L power b, T power minus b. Okay. If you want one more step means you can add it over there. Or directly if you are familiar to write means directly you can write L power b. Okay. And here one more L power c I am having. Okay. So L power b plus c I will do because bases are same means these powers can be added. Clear? So L power b plus c and next T power what I am having? M completed, L completed, here L completed, here only T is remaining. So T power minus 1 into b is nothing but what? T power minus b. Clear? Now just compare the coefficients, compare the powers. Comparing powers of m, L, T. Now just check. Here I am having m, here I am having m. Clear? M, if simply I am writing m means that is nothing but m power 1. Clear? Yesterday I had told you. And this is simply L means this is nothing but L power 1. Okay. So now just compare. Here I am having m, here I am having m. Both the bases are same. So powers must be here equal. Correct? So here I am having equal to sign. So powers are nothing but equal to each other. So what I can get? A is equal to 1. Okay. So next L power b plus c, L power 1. So what I can write? L power b plus c, L power 1. That means b plus c is equal to 1 or 1 is equal to b plus c. Clear? So b plus c is equal to 1 or 1 is equal to b plus c also you can write. Next last step what I am in? T power minus 2, T power minus 3. So what I can write? minus b is equal to minus 2. Clear? Are you all following? So here I got a is equal to 1. Our main aim to calculate what are the powers here. Okay, a, b, c we are going to calculate. So basically I got a as 1. So here minus b is equal to minus 2. Minus minus will get cancelled. What I will get? B is equal to 2. Clear? Are you all understanding? So final step, I got a, I got b. I should have to calculate c. Here I got b. Substitute this b here. Okay, how much b I got? 2. So 2 plus c is equal to 1, or c is equal to 1 minus 2. C is equal to minus 1. Got it? A I got 1, B I got 2, C I got minus 1. So this A, B, C values you should have to substitute back in equation number 1. So if I substitute in equation number 1 means what I will get? F is equal to K m power A. Clear? K m power A means A how much I got? 1. M power 1. V power B. V power B how much I am having? 2. Clear? Next R power C. So R power C means C value is minus 1, R power minus 1. Clear? This K is nothing but a constant experimentally determined that this value is found out to be 1. This value is equivalent to 1. So what I can write here? F is equal to m power 1 means simply m I can write. Clear? V power 2 means V square. R power minus 1 means in denominator I can write R power 1. Clear? Or in denominator I can write it simply R. Clear? So this is our final expression. F is equal to mv square by R. We had derived this equation through the method of dimensional analysis. Clear? So let me repeat all the steps. They will give you either formula. Clear? To derive this formula they will give you, or in sentence manner they will be giving you. The force, centripetal force experienced by a body which is rotating in a circular frame of radius r, okay, that is dependent on mass of the body, velocity of the body and radius. Only that much they will be giving. If they are giving in sentence means they won't give, it depends on square of the velocity, like that they won't give. Clear? So simply if they had given means we should have to write it in proportional manner. Okay, centripetal force experienced by the body, it is proportional to mass of the body, velocity of the body and radius. Okay, choose the powers as A, B, C. Next, remove this proportionality symbol, introduce a constant that is nothing but K. So if you substitute, if you introduce K means you will be going to get this equation, and when you got this equation, treat this equation as 1. Okay. Next, for each term you should have to write dimensional formula. Write in dimensional formula for each term. For force, that is nothing but ml t power minus 2. Clear? Next is equal to K is nothing but the dimensionless constant. We are not going to write any dimensions for this. Next, m, here I am having, m is nothing but mass of the body, so capital M. Next, V is nothing but velocity, Lt power minus 1, whole power P as it is I had mentioned here. Next, R is nothing but radius, which is nothing but basically length, so L power C. So here left hand side as it is I had written, in right hand side also same manner m/t I had written. Why I got B plus C here, L power plus B and one more L power C I am having. Clear? So what we can write, L power B into L power C is nothing but L power B plus C. Clear? Next, by comparing the powers of MLT you will get A, B, C values, and finally these values you are going to substitute back it in equation number 1, and experimentally K value is to be found out 1, and finally you are going to get the desired equation, that is nothing but F is equal to mv square divided by R. Clear? Are you all following? Note it down. Shall I erase the board? Okay. Now come back to this question. In this question they have given the pressure exerted by a liquid. It depends on height of the liquid column. Clear? Density of the liquid and acceleration due to gravity. What they are giving? The pressure exerted by a liquid. Clear? When a pressure is exerted by a liquid, that is directly proportional to, or it depends on height of the liquid column and density of the liquid and acceleration due to gravity. Okay, derive the required relation for pressure using the method of dimensional analysis. In this problem, they had not given any formula. Yeah, so we should have to derive it now. Okay, solution. So first of all, we are going to derive required relation for pressure. Clear? So pressure P is equal to, on what all factor it is depending? Pressure is exerted by a liquid. It depends on height of the liquid. Okay, height of the liquid column. That means this P is dependent. Okay, I will be writing this proportionality symbol. So this P is proportional to H power A, because I don't know this power. It depends on height of the liquid column and density of the liquid. Okay. For density, I will be taking this symbol. This symbol is known as rho. Clear? This is nothing but a rho. It indicates density. So this rho power B I will take. Next, what they had given? Density of the liquid means rho. Next, acceleration due to gravity. Acceleration due to gravity means G. Okay, this G power C I will take. So the pressure exerted by a liquid column, this P is directly proportional to, or this P is depends on height of the liquid column, density of the liquid and acceleration due to gravity. We don't know these powers. Take it as A, B, C. Clear? Then we are going to remove this proportionality symbol. Same steps. P is equal to K into H power A, rho power B, G power C. Clear? Okay. Next, let us check what we are having. We have to write dimensional formula for each term. Okay, writing dimensional formula. I will be writing DF in short. Writing dimensional formula for each term. So what I will get? So P means pressure. Pressure is nothing but what? Force divided by area. Okay. So directly, if you are unable to write pressure means force by area, you take it. Force divided by for area. Force, what is the formula? Force is nothing but mass into acceleration, correct? No? So what I can write? Mass for m. Acceleration means you already know, that is nothing but LT power minus 2. Clear? This is nothing but minus 2. Next, force divided by area. Clear? Area means what? The dimensional formula for area is nothing but what? L square. Correct? No? It is 2 in length. Dimensions is nothing but 2 in length. Okay? L square. This is equal to. K is dimensional is constant. Leave it aside. Now we have to go for this H. H is nothing but height of the liquid column. Okay? Basically height. Okay? That is nothing but length. So what I can write? L power A. Clear? Next, rho. Rho means what? Density. Density means mass by volume. So mass by volume, yesterday we had discussed, that is nothing but mass by volume means length into length into length. Clear? Divided by volume it is. Density means mass divided by volume. So ml power minus 3. Clear? Whole power B. Next, G. G means what? Acceleration due to gravity. Acceleration due to gravity is nothing but basically acceleration term you should have to write. Acceleration means LT power minus 2. Clear? Whole power what I am having? C. Clear? Are you all followed up to this step? Now what you have to write? First simplify this one. Write in the form of MLT and this also in the form of MLT. So here now check M as it is, I will note it down. M. Here I am having L power 1. This L square, if I take it to numerator means it will become L power minus 2. L power plus 1, L power minus 2 will give me L power minus 1. Correct now? Next, here I am having T power minus 2. Okay. Now here, check which term you are having M. Here you are having M. M, it is complete whole to the power of B. That means what I should have to write here? For M term, it is nothing but M power B. Clear? First term I am having M, that's why I am writing M here. Okay? Sir, why you left this? Don't ask. Next term I am going to consider for length L. Clear? M power B. Next. First term M, m I had written here. Okay, only here I am having m power b. Next, second term l. So I should have to cross check l wherever I am having. In this term also I am having l. In this term also I am having l. In this term also I am having l. So first go for this term. What I can write? L power. It is nothing but a. Clear? L power a. Here L power minus 3 into b. It is nothing but L power minus 3b. Correct? L power minus 3b. Here only I can write it. If bases are same, powers will be get added up. Remember, here I am having minus 3b. That's why as it is I had written minus 3b. Clear? So if it was plus 3b means directly plus 3b. It is nothing but a plus of minus 3b. Clear? So plus into minus will turn out to be minus. So a minus 3b. Next, L where I am having here. So L power c. Correct? So this is nothing but L power plus c. So that's why here I am writing plus c. Clear? So m completed, L completed. Remaining term is t. So here I am having t. So in this term check where you are having t. Only here you are having t power minus 2 whole power c. That means t power minus 2c. Clear? Are you all following? Now just comparing the powers of MLT. Comparing powers of m comma l comma t. So m power 1 I am having here. Okay, if nothing is, if I had not written here anything means that is treated as 1 only. Correct? No? If I had written only m means that is m power 1. So here I am having 1, here I am having m power b. So what I can write? Equating the powers, 1 equal to b or b equal to 1. Yeah, directly I got b value. Next check for this one, a minus 3b plus c for L power. Here L power minus 1 you are having. That means a minus 3b plus c is equal to minus 1. Power of L here is minus 1. That is equal to power of L here. A minus 3b plus c. A minus 3b plus c. Clear? Next, here what you are having t power minus 2c. Here t power minus 2. So what I can write? Minus 2c is equal to minus 2c is equal to minus 2. Okay, so from here minus 2 will get cancelled. Remaining factor is nothing but c is equal to 1. I got b value, I got c value, substitute here. We will get a value. So a value we don't know, as it is written a minus 3 into b. B value is 1. Okay, substitute here. 3 into 1 plus c value is 1. So substitute here, it will become 1 is equal to minus 1. So if you simplify means what you will get? A minus 3 into 1 is minus 3 plus 1 is equal to minus 1. So a is equal to minus 3 plus 1 is nothing but minus 2. So minus 2 if I bring it here means it will become plus 2. Plus 2 minus 1 means it is nothing but 1. Correct? So a value I got 1, b value I got 1, c value I got 1. So this a, b, c values again you are going to substitute it in our equation number 1. Call this equation number as 1. Whenever you are going to write this equal to sign, by removing this proportionality sign, treat that equation as equation number 1. Clear? Next. Okay, are you all getting? So just writing dimensional formula for each term. Okay, we came across this point. A value, b value, c value, all three I got. Just substitute here. Experimentally found this k values turn out to be 1. Okay, if this turn out to be 1 means, if you substitute a, b, c values means finally what equation we are going to get? P is equal to h power 1, rho power 1, g power 1, or h rho g. Or I can write it as rho g h. Yeah, this is our required desired equation for a pressure exerted by a liquid of a column of height h, and it is dependent on and the pressure is related with height of the column h and density of the liquid and acceleration due to gravity. Clear? Here I had written P is equal to rho g h. That means simply by substituting here value 1, because this k value experimentally found out to be 1, h power 1, rho power 1, g power 1. So Shall I erase the board? Clear? Next one, we are going to discuss about one more formula to derive with the help of this dimensional analysis. Clear? So centripetal acceleration is given by v square by r. Okay? Clear? So where a is nothing but what? Centripetal acceleration, v is nothing but velocity of the body, r is nothing but radius of the circular track. So we are going to derive this relation actually. So how we are going to write? A is proportional to v power a, r power b. If I remove this proportionality symbol, means a is equal to k into power v power a, r power b. So now we are going to write dimensional formula for each term. Clear? You have to write that line, writing dimensional formula for each term. Then for acceleration, what is the dimensional formula? L into t power minus 2. Clear now? Next, k is nothing but constant. Leave it. V is nothing but velocity. Velocity is nothing but what? Lt power minus 1 whole power a. Correct? This v is nothing but Lt power minus 1. This whole power a. R is nothing but radius, basically length, whole power b. So here we won't have any m quantity. Okay, just leave it as it is. Lt power minus 2. Okay, here also write in the manner of Lt only. So here I am having L, here I am having L. L power a, L power b, L power a plus b. Clear? Next, t power minus 1 into a, that is nothing but t power minus b. Are you all following? Now just compare. By comparing powers of by comparing the powers. So what I can write? Powers of MLT. So this is nothing but t power minus 1 into a, means this will become t power minus a. Clear? So by comparing the powers of MLT, what I can write? M we don't have, just write LT. Clear? By comparing the powers of LT, check what we are going to get. L power 1, L power a plus b. Clear? Nothing is there means 1. 1 is equal to a plus b, or a plus b is equal to 1. A plus b is equal to 1. Next here check what I am having. Minus a, t power minus a is equal to t power minus 2. That means minus a is equal to minus 2, or minus minus will get cancelled. A is equal to 2. Yeah. Next, this a value you just substitute over here. A value is nothing but 2. 2 plus b is equal to 1. B is equal to 1 minus 2. B is equal to minus 1. So, if you substitute a and b values back to this equation, okay, equation number 1. So what I will get? A is equal to k into bracket v power a. That means a is 2. That's why v power 2. Next, r power b means r power b is minus 1. That's why r power minus 1. So what I can write? K value experimentally found out to be plus 1. Okay, it is equal to 1. A is equal to v square. Here r power minus 1, if I take it to numerator, means r power 1, or simply r. So v is equal to, A is equal to v square by r, where a is nothing but centripetal acceleration, v is nothing but velocity of the object, r is nothing but radius of the circular path. Are you all following? Shall we go to one more example? Shall I erase the board? Here I had written b is equal to minus 1. Clear? That is nothing but b is equal to minus 1. Clear? Okay. Next one we are going to derive v is equal to root of g into r, where v is nothing but velocity of the satellite which is moving very close to earth. Okay, don't worry, these formulas I know you don't know still. Yeah, you will be coming to know v is nothing but velocity of the satellite which is moving close to earth, that is dependent on acceleration due to gravity. This is nothing but acceleration due to gravity. Okay, and r is nothing but radius of earth. Okay, r is nothing but radius of earth, g is nothing but acceleration due to gravity, v is nothing but velocity of satellite. Velocity of satellite moving close to earth. Clear? V is nothing but velocity of satellite moving very close to earth, g is nothing but acceleration due to gravity, r is nothing but radius of the earth. So now our duty is to derive this formula. Clear? In examination they may give you directly to derive this formula using dimensional analysis, or they may give you the velocity of a satellite moving very close to earth's surface, that is dependent on, okay, that is dependent on acceleration due to gravity and radius of the earth. If they had given in that manner also, means directly you are going to write it as, in solution part, v is directly proportional to, okay, v is directly proportional to, first one acceleration due to gravity, okay, power a, and radius of the earth power b. Clear? So what I can write, v is equal to k into g power a r power b. Clear? V is equal to k g power a r power b. So I will be calling this equation as equation number 1. Next what I will be doing, writing the dimensional formula for each term. Clear? Writing dimensional formula for each term. Clear? So can you write dimensional formula for each term, and can you simplify? V is nothing but what? Velocity. Velocity is nothing but what? Displacement divided by time. So displacement divided by time, it is nothing but displacement is L divided by time is t power minus 1. Correct? No? Lt power minus 1. K is dimensional is constant, leave it. G is nothing but acceleration due to gravity. Acceleration due to gravity, it is nothing but what? Basically it is a acceleration. So what I can write for acceleration, meter per second square, SI unit. Using that also you can write, meter means it is nothing but length quantity, per second square means p power minus 2. Correct? No? So g is nothing but acceleration due to gravity, Lt power minus 2, whole power what I am having, a. Okay, whole power a. Next one more quantity, that is nothing but r. Radius of the earth is nothing but, it is basically length. So what I can write, L whole power what I am having, b. Here. Now just comparing powers of L comma t. Okay, because here we won't have any m factor, so L t only we are having. So comparing the powers of L and t. So what I can write, so you can just compare here L power 1, L power a, L power b, or you can write one more step over here. Before going to comparing, write one more step and then we can compare. So how we can write this step? Left hand side as it is, Lt power minus 1. Yeah. Next right hand side, L power a, L power b. So what I can write, L power a plus b. Yeah. Next t power minus 2 whole power a. That means t power minus 2 whole power a is equal to t power minus 2. Now you can compare. Comparing powers of L comma t. Yeah. So L power 1, L power a plus b. So 1 is equal to a plus b, or a plus b is equal to 1. Correct? A plus b is equal to 1. Next t power minus 1, t power minus 2a. That means minus 2a is equal to minus 1. Minus 2a is equal to minus 1. So here just check, minus minus will get cancelled. So A is nothing but what? 1 divided by 2. Correct now? A is nothing but what? 1 divided by 2. So if you substitute this A value over here means what I will get? 1 by 2. Clear? A value is 1 by 2. 1 by 2 plus B is equal to 1. So what I can write? B is equal to 1. If I take this 1 by 2 to the right hand side means 1 minus 1 by 2. So 1 minus 1 by 2, that is nothing but 1 complete term minus half of that. How much will remain? 1 minus half is nothing but half will remain. Here 1 minus 1 by 2 is nothing but 1 by 2. So factor B we got it as, power B we got it as 1 by 2, power A we got it as 1 by 2. Correct? Huh? So now substituting A and B back to equation number 1. Okay, in this equation we are going to substitute it now. So what I can write? V is equal to K as it is G power A. G power A value is how much? 1 by 2. That means K into G power 1 by 2. Okay. Next R power B. R power, what is B value? 1 by 2. Correct? V is equal to K G power 1 by 2, R power 1 by 2. Experimentally, K value is to be determined. That is nothing but equivalent to 1. So V is equal to A value is 1, G power 1 by 2, R power 1 by 2. How I can write? G power 1 by 2, R power 1 by 2. Okay, this is nothing but root G into root R, which is nothing but V is equal to root of GR. Yeah. So the given equation is nothing but V is equal to root of GR. Okay, we had arrived at the same equation, V is equal to GR. But how we had arrived? With the help of dimensional analysis. Yeah. Shall I erase the board? You can copy it down. Okay, shall I erase the board? Clear? Shall we go to one more example? The kinetic energy of the body, okay, which is moving. That kinetic energy is given by, already you know that E is equal to what? Half mv square, where m is nothing but mass of the body, v is nothing but velocity of the body. Shall we start? So E is directly proportional to, what is our first step? Energy, kinetic energy is proportional to, this half is nothing but constant now. We are not going to consider that because we are not going to write any dimensions for constant, correct now? So E is directly proportional to m power a. Okay, next v power b. We don't know a, b, we are going to determine a and b values. Okay, powers a and b we are going to determine. So E is directly proportional to m power a, b power b. So what I can write? E is equal to, if I remove this proportionality symbol means E is equal to, what I can write? K into m power a, b power b. Clear? E is equal to k m power a, b power b. Okay, next let us call this equation as equation number 1. Next we are going to writing, what is our next step? Writing dimensional formula for each term. Okay, in exam don't write only df, okay, write completely dimensional formula. So writing dimensional formula for each term. Energy, what is the dimensional formula for energy? Clear? So writing dimensional formula for each term. What is the dimensional formula for energy? Yes, anybody know? E is equal to half mv square. In that manner also you can calculate what is the dimensional formula for energy. Or yesterday I had told you one more important thing. That means dimensional formula for energy as well as dimensional formula for work done, both are same. Correct now? For dimensional formula for work done, what we had written yesterday? Work done is nothing but what? Force into displacement. Yeah? Shall we go according to that? Dimensional formula for energy, it is nothing but force into displacement. First I will write force. Clear? Force is nothing but mass into acceleration, m into l into t power minus 2. Clear? Into displacement means again L. Correct? Force is nothing but mass into acceleration. Okay, force into displacement L. This is nothing but dimensional formula for energy. In simple words, what I can write? L power 1, L power 1 means I can write here L power 2 and I can erase this L. So ml square t to the power of minus 2. Clear? Next, I will just shift this here. Okay. Is equal to k constant. M is nothing but mass of the body, which is nothing but m. Clear? Okay. M power, what I am having? A. Yeah, m power a. Next, v is nothing but velocity, what I can write? Meter per second. Okay, SI unit is meter per second, but velocity is nothing but what? Displacement divided by time. Okay, displacement made per unit time. So what I can write? L t power minus 1 whole power b. Okay, so m l square t to the power of minus 2, m power a, l t power minus 1 whole power b. So just write this in terms of mlt, m l square t to the power of minus 2, okay, is equal to. So here what I can write? First term m, as it is m, I will be writing here. M power a I am having, m power a. Next term l power b. Okay, m l square. Sorry, m first term, second term is l. Here also first term m related I had written, second term l related I have written. Next third term is t. So t power, here minus 1 into b. What is that? Minus 1. Here m power a, l power b, t power minus b. Sorry, m power a, l power b, t power minus b. Now just compare powers of m, l, t. So what I will get? So here m power 1, m power a. So what I will get? 1 is equal to a or a is equal to 1. Correct, no? Next, l power 2, l power b. That means 2 is equal to b or b is equal to 2. Clear? Next, last step, t power minus 2, t power minus b. So what I can write? Minus b is equal to minus 2. Okay. Here also I got b is equal to 2. So here also b equal to 2, b equal to 2. Here a equal to 1. So this a and b values we are going to substitute back it in equation number 1. So if I substitute it in equation number 1 means what I will get? E is equal to k. Clear? M power a. Clear? Small m power. Small a value how much I got? 1. Clear? Next, v power b. V power b value how much I got? 2. Okay. So experimentally found that this k value is treated as half. Clear? So E is equal to half. This m, as it is m, I will be writing v square as it is v square. So kinetic energy of the body, it is given by half mv square. Clear? This is nothing but square. Are you all following? Shall I erase the board? Clear? So now we are going for next application. Okay, third application, to convert one system of unit to another system. Okay. So example, how they will be asking means, convert MKS unit of force into CGS unit. Clear? So in examination they will be giving you in this manner, convert MKS unit of force into CGS unit. Clear? Or sometimes they will be giving it as, show that 1 Newton is equal to 10 to the power of 5 dynes. So step by step I will be explaining. Listen carefully. So solution. First one we should have to note down what is MKS unit of force. Clear? MKS unit of force MKS unit of force is nothing but Newton. Okay, remember this is nothing but Newton. Next, in which we have to convert it, in which unit we should have to convert it, we have to convert it in CGS unit, correct? No? So CGS unit of force is nothing but dyne. Yeah? MKS unit of force is nothing but Newton and CGS unit of force is nothing but dyne. Clear? Now we are going to consider as MKS units and CGS units for MLT. Clear? That means in MKS units we are going to consider M1, L1, T1, and in CGS units M2, L2, T2. Yeah. Okay, lastly, finally we are going to consider N1 and N2. Already I had told you what is the relation between numerical value and its unit. Clear? Here I had written N1, here I had written N2. Clear? So in MKS units, okay, mass we are going to treat it as what? In the units of kilogram. That means 1 kg. Okay, for M1 we are going to treat it as 1 kg. Next, in CGS unit we are going to measure mass in the units of grams. Okay, here I will be taking 1 gram. Okay. Next, for length in MKS unit we are using 1 meter. Yeah? In length we are using 1 meter. In CGS units 1 centimeter. Clear? Next, in time both the units will be in second only. Okay, T1 is equal to 1 second, T2 is equal to 1 second. Next, N1 is equal to 1 we are considering because we are going to measure what is the value for MKS unit in terms of CGS unit. That means if we are having 1 Newton of force, that is equivalent to how much value in CGS unit we are going to consider. So N1 is equal to 1. This N2 we are going to calculate it. Clear? Now how to go for this? How to calculate this is nothing but this is very simple process. N2 is equal to, we are going to write this step, N1 into bracket. So here we are having M2, here we are having M1. Clear? First we are going to consider MKS unit of force and then we will be considering CGS unit of force. Next, we are considering MKS values as M1, L1, T1 and CGS values in the units of M2, L2, T2. Next, we are writing this N2 is equal to N1 into bracket M1 divided by M2. Here, next L1 divided by L2 and one more factor T1 divided by T2. And this whole power A, B, C we are going to consider. So what are this A, B, C is nothing but first we should have to know what is the dimensional formula for force. I had already told you what is the dimensional formula for force. Dimensional formula force. Force is nothing but what? Mass into acceleration, correct? No? So what I can write here? M as mass and acceleration is nothing but LT power minus 2. So the powers of M, LT we are going to consider it as A, B, C. That means A value will be 1, clear? B value will be 1, T value will be minus 2. Okay, in that order. So N2 is equal to N1 value what I had considered here for 1 value. Clear? I hope you are not able to visible that. You are okay. N1 value here I had taken it as 1. Here N2 value we are going to calculate. Correct? No. So N2 is equal to N1 value if I substitute 1 into anything is nothing but anything. So 1 I can write here or we can leave it. Okay, it's our convenience. So M1, M2 we should have to substitute. M1 is 1 kg. Okay, first substitute 1 kg. Whole divided by. M2 is nothing but what? 1 grams. Clear? 1 gram. Whole power. A value what we are having? 1. Correct? No? A, B, C are nothing but powers of M, L, T in force. Clear? Remember. Next. L1 by L2 I should have to substitute. L1 is nothing but what? 1 meter. L2 is nothing but 1 centimeter. Shall I substitute? L1 as 1 meter, L2 as 1 centimeter. Okay. Whole power B. B is nothing but how much? Value 1. Next T1 by T2. 1 second by 1 second. Whole power C value minus 2. Clear? So finally N2 is equal to, so 1 into anything, I am just dropping this one. So 1 kg, this kilogram we are going to convert it in CGS units, which is nothing but in CGS, centimeter gram second. Clear? For length we are using centimeter units, and for mass we are using grams. Correct? No? Here we are having mass factor actually. So here we are having kilogram as the unit. So this kilogram we are going to convert it into grams. So 1 kilo, I had informed you what are the prefixes values. So kilo stands for how much? 10 to the power of 3, or what I can write it as 1000. 1000. This 1 kilogram can be written as 1000 grams whole divided by 1 gram, as it is nothing but 1 gram. Clear? Next, here it is in MKS unit, which is nothing but 1 meter. This MKS unit of meter we are going to convert it into CGS units. In CGS units we should have to convert it into centimeter. So in 1 meter how many centimeters will be there? In 1 meter how many centimeters will be there? If you are having 1 meter scale, means how many centimeter values you are going to get over there? That is nothing but 100 centimeter, or in simple words what I can tell, 100 centimeter constitutes 1 meter. So in the place of 1 meter, I will be mentioning 100 centimeter, and denominator as it is, which is nothing but 1 centimeter. Clear? Next, this is nothing but 1 second by 1 second. Clear? 1 to the power of minus 2. 1 power anything is nothing but 1. Remember, 1 power infinity value is also 1 only. Clear? So here 1 second by 1 second value is nothing but 1. So 1 power minus 2 is nothing but 1 only. So from here what I can get, M2 is equal to this 1000, how I can write? 10 to the power of 3. Clear? And here what I am having, 100. So what I can take it as 10 to the power of 2. That means 10 to the power of 3 into 10 to the power of 2. So finally, which implies that N2 value will be finally what I am going to get, 10 to the power of 5. Clear? N2 value 10 to the power of 3, 10 to the power of 2. If bases are same, already I had informed you, power should be get added up. So 10 to the power of 3 into 10 to the power of 2 will result as 10 to the power of 5. Clear? So now, shall I erase this part? So we know the relation between a numerical value and a unit. What is that? It is inversely proportional to unit. That means numerical value is inversely proportional to unit. And one more step, what we had written, n into u is nothing but what? Constant. So here we are having two system of units. So what we can write, n1 u1 is equal to n2 u2. Clear? n1 value what we had chosen earlier in that column, 1. Okay. Units in earlier case means which case we are having earlier case as nothing but MKS system. In MKS system, unit of force is nothing but what? Newton. So 1 Newton is equal to N2 value, how much we got? 10 to the power of 5. Clear? So that I will be substituting here, 10 to the power of 5. And U2, that means unit in our another system, secondary system, that is nothing but CGS system. In CGS system, unit for force is nothing but dyne. Clear? So 1 Newton is equal to 10 to the power of 5 dyne. Okay? In theory examination, sometimes they will be asking this derivation for 5 marks. Okay? Show that 1 Newton is equal to 10 to the power of 5 dyne, or convert MKS unit of force into CGS unit of force. Clear? So don't waste your time, study well. So again we are going to meet it in our next class. Clear? Thank you.